All right. Whoa, that's loud. Hi, guys. I'm Trent. So let's all just be a little bit quieter, please. I'll use the white noise trick. Thank you. You've eaten, your stomachs are calm. Let's learn a little bit about AI and blockchains. Let's get started. So today I will talk about blockchains for artificial intelligence. It's pretty fun, and it's actually not just buzzwords, as you will see. So a lot of you might have played Where's Waldo when you were children, or maybe still now, just like the coloring books. This here, what you see, is sort of like Where's Waldo, but for airplanes. Try to find the airplane in the noise. It's actually pretty easy, even for an AI, to find this airplane. But this AI actually not only found the airplane, it found the orientation. Pretty cool, right? Well, it's actually within a much broader scene. It wasn't doing just airplane finding. It was identifying all the different objects, from the airplane on the top left and its orientation, to the tree, and a bunch of humans below. Maybe one of those humans is named Waldo. Who knows? Now, AI algorithms are also used to get even more general, for example, scene description. And if we look at this picture here, the AI thinks that it is a cat sitting on a toilet in a bathroom. No one ever claimed that AI algorithms are 100% accurate, so it's a funny-looking cat. But you know what? They've actually become good enough and accurate enough to use in a whole bunch of use cases. In fact, you might not realize, but AI algorithms have actually been in use for decades and decades, going back to the 60s and 70s and 80s in industrial use. In the field of CAD, for example, where I come from, for the designing of computer chips, they've been used since the 80s. This is actually where the field of simulated annealing came from. This iPhone here has about 15 chips inside it. Every single one of them was verified with an AI algorithm. And not just any AI algorithm. It was actually running on thousands of distributed machines for hours at a time to verify whether or not this chip, and each chip, was a 1 in a billion chance of failure or 1.1 in a billion. How do I know this? This is actually software that I helped create in my previous career. So I kind of crossed from the side of AI to the dark side of blockchain. So basically, there's real-world applications that have been out there for a long time in the world of AI. But of course, what's happened actually, in the last 5 years especially, it's taken off. And there's a reason for this. It started happening in the early 2000s. Researchers started to notice. A funny thing, what you see in this plot here is, on the x-axis, the number of data points, and the y-axis, the accuracy. And if you're an AI researcher, when I was doing AI research in the 90s, I would get a data set. I would get maybe 1,000 or 10,000 samples, and I would spend all my time playing with that data just to try to make things a little bit more accurate, inventing new algorithms. But what researchers discovered as early as 2001 was, don't worry about the algorithm, worry about the data. And as you add more data, your accuracy goes way up. Here, for example, they had 10,000x more data with the same algorithms, and it reduced the error from 25% down to 3%. So all of this fun of playing with algorithms kind of went away, and it was really much more actually about the data. Data was unreasonably effective. In fact, fast forward 10 years from this initial realization from Google and Microsoft and others, and data has been called the world's most valuable resource. And with reason. These companies below that have data at their very heart and soul, Google, Amazon, and so on, have become the most valuable companies on the planet. And it's really a very simple formula. More data and compute power leads to more accurate models, which leads to more money, right? For selling ads and so on, right? Some of the brightest minds selling ads, but guess what? There's dollars there. So let's ask, what do the AI algorithms look like in the context of sort of the broader compute stack? And for first principles, let's look at the three elements of computing: storage, processing, and communications. Within each, these actually have subcomponents. With storage, we've got file systems, things like HDFS, Hadoop, S3 with Amazon. And then for databases, these are the big data databases that are powering things in AI, MongoDB, Cassandra, and more. With processing, business logic, like CPUs and Amazon EC2, don't play as much of a role. What's really playing a role for the world of AI is things like NVIDIA GPUs, which have massive thousands of processors running in parallel. The Google Tensor Processing Unit, which they just opened up to the cloud last week. MapReduce and Spark, which are ways to have massive batches of compute. So these are the things that are driving AI on storage for the data and processing for the compute. So you might think, well, isn't this cool? AI is transforming things, all of this. But the fact of the matter is, all is not well in the world of AI. There is massive data hoarding happening. Big guys have all the data, right? This is their moat. There's weak data history. It's the classic problem of garbage in, garbage out for AI algorithms. Where did your data come from? Is your model actually accurate if the the training data is accurate? And if you want to buy the data, it's super expensive. So this is just a few problems. There are many more. We've been asking, can decentralization help? And another way of asking is, can you use blockchain technology somehow to help unlock AI, to solve some of the problems with artificial intelligence? And we've been coming to realize that one of the pieces is perhaps a shared database with planetary reach. And sort of as a quick review, memory lane of databases, if you go back to the early 80s, that was the house that Larry Ellison built with Oracle. And what that was basically you could actually query large mountains of data with a very structured query language, SQL itself, right? And that became one of the most valuable companies on the planet. Following that, there was other blue ocean databases that emerged. MySQL, which basically made it easy to build websites with databases. Big data databases like Mongo actually allowed these websites to scale in the early 2000s. And more recently, we see that blockchain databases are in this long line of blue ocean databases, bringing in the decentralization. So not just distributed databases, which distribute the compute loads and storage, but decentralized, spreading the control. And that can have major ramifications, as we'll show. So with this, there's actually been an emerging compute stack that's decentralized. And these elements within this are storage, processing, and communication once again. And within that, we've got file systems, database, and eGold or eCash for storing tokens of value. And there's some emergent players here, right? For file systems, a key one is IPFS and Filecoin. Juan will be following me giving his talk. Swarm, and there's others. In the world of database, decentralized databases, this is what I spend my time on with BigchainDB and its public net, IPDB. And with eGold and eCash, there's Bitcoin. It's really about this store of value, or Zcash, and basically every other blockchain out there that has its own tokens. In business logic, for the processing side, decentralized business logic, this really is smart contracts. It's a better label, decentralized business logic. So be it. And something that's emerging, actually, is high-performance compute, right? How do you have large-scale computation happening in the world of AI? And we've had things like TrueBit, Golem, and iExec emerging. These aren't quite mature yet, though. So we've also seen that people are running virtual machines, using VMs as assets, this sort of thing, and simply client-side compute on their mobile phones, inside the browser, et cetera. And in communications, too, there's things happening. So within the world of AI, there's a few things here that are the most important, the building blocks that matter the most. First of all, file system, where IPFS is probably the most mature. Database, BigchainDB, IPDB. And in high-performance compute, the VMs and the client-side compute is the most mature. So this is really the tools, if you want to do AI applications related to blockchain, these are the ones you're probably going to be working with. Let's talk about some of these applications. There's some really cool things emerging. So on the problem of data hoarding, there's a problem where if I'm a designer of 3D parts and I go to manufacture it, I send it off to the factory in China or something. If that design gets stolen, someone else can manufacture it, and so on. And the problem is, if I'm a manufacturer, I have to talk to every single design company and know what's going on. We have these data silos. But imagine if there was a pool of all of this data together that all of the different designers and manufacturers work together on. And that way, with that, you could actually identify fraudulent copies, et cetera. So this is actually what we're working on with Cognizant Energy, 3D Maker Zone, Intel. And it's basically leading to more accurate models for fraud prevention in supply chain. Another example for fraud prevention in supply chain is with diamonds. So in this case, we worked on a project where we had pooled data from multiple certification houses. And we realized that there's very many factors to identify whether a diamond was fraudulent or not. But a key one was the idea of price prediction. So when a diamond shows up on eBay, how do you know whether or not it's fraudulent or not? Especially given that overall, there's a 40% fraud rate in diamonds. And what we did was we built models that actually predicted the price as a function of the 4 Cs, the carats, the color, and more. And with that, we could actually predict the price within 1% accuracy. So if the price actually had variation beyond that, we would know very quickly. There's a lot of other problems, too, that actually the AI combined with blockchain can help. So here's one example. In this case, I have a design. In this case, it's a cart tree, a decision tree that I did during my PhD 10 years ago. And if I want to sell this thing, it's going to be a big pain in the butt, right? So what I can do now, though, is I can just go and timestamp this, claim copyright, timestamp it onto the blockchain, and then simply license it. And this is actually where we started 4 years ago when we were working on Ascribe. We actually ran into issues of scale, and that's actually what led us to BigChainDB. But here, I've got a decision tree that is ascribed. If one of you wants to buy it, an edition from me, just come to me afterwards, and I'm happy to sell it to you. So $5, or 10 if you want, edition number 3. So that's an example. Another one, which we're not working on, but I think is super cool, is Numeraire. And they are basically also addressing this problem of how do you monetize algorithms easily. They're essentially a hedge fund in a box. So they're a hedge fund, but rather than 5 geniuses in a corner dreaming up new algorithms, they actually are using a community of 12,000 data scientists who are submitting algorithms to predict the stock market and trade. From that, each scientist was actually getting winnings proportional to the, how well his algorithm did. Now, this had a problem, and the problem was the more that one person's algorithm did, the less winnings others would get. It was a zero-sum game. So what these guys did was they tokenized it. And by doing the tokenized, it made it from a zero-sum game to a positive-sum game. And that allowed this rising tide lifts all boat phenomenon to occur. So it's a very cool, clean example of the value of tokenization. Keeping going, also when we were working in the Ascribe days, we had a problem. People didn't want to put their art and other images onto any blockchain system or anything online at all because they were worried if it showed up at all, then maybe it's gone for good. It's spread for good, they lose control. So we said, what if we could give you visibility into where this stuff is spreading? So we crawled the web. We spent hundreds of thousands of dollars of compute power crawling the web with Amazon. So AWS loved us, actually. And we had 15 billion images. And from that, we had AI technology to basically do the equivalent of Google reverse image search, but with provenance of copy. So what you see here, I did a search for Doge. And you can see, actually, right in early 2014 was when it started taking off with Dogecoin. And since then, there are now more than 2,600 copies spread across a whole variety of different websites. Each website is a different color here. So you can use this today if you want. Just go to Where on the Net, and you can actually search for the spread of anything, your company's logo, for example. So keeping going forward, if I'm building a data model, and if I'm building an AI model, what about the data itself? What if I don't know where it comes from? What if someone gives me garbage data? Then I'm going to actually have a garbage model. What if instead that every time I ingest data, that data is signed. I know the full provenance of the training data. And then when I train the model, also, the process from that training is signed. Every single step along the way of model building and model simulation is signed. This is actually possible now. What you do is you simply timestamp the data to something like a public database, like IPDB, and store the data itself, the model itself, into something like IPFS. And then you have basically these immutable audit trails of AI, data, and models. This is incredibly powerful, especially when you have things coming along through the European Union and so on, where you actually have to explain what your algorithm did, otherwise the regulators come after you. So on this, here's a very specific example. We're working with Innogy, Riddle Code, and others on something called CarPass. And CarPass solves the issue of when you go into a used car lot, how do you know what you're buying isn't a lemon? How do you know you're not getting ripped off? Imagine if you saw the whole history of that car, right? From the day that it was purchased, even the days that it was manufactured and so on, every repair, every oil change, and so on. And with that, and everywhere it drove, et cetera. So, and with that, then you could even data mine it. And that's actually what's happening here. So we actually have, this is an app that's running. You can come to our booth and see it even. And basically, it is data mining what's going on with the car data. And you see some of the plots and data mining below. Interestingly, also, it points to a very simple architecture for blockchain deployment, if you like. You can actually build a simple web page app, a single-page web app, and below that, have a database, IPDB. That's it. You don't need anything else. So this is one of the alternative architectures you can have to quickly roll out blockchain systems. Keeping going, on this problem of compute and storage being expensive, we're seeing this emergence now of tokenizing file systems for massive data storage, as well as high-performance compute, right? And there's quite a few in each. And I apologize if I missed some, but these are some in the world of file systems. We've got storage with a J, Filecoin, Swarm, Sia. On high-performance compute, we've got TrueBit, Golem, iExec, and more. So this is really very exciting, and it really promises to pull down the cost of storage and compute more. Keeping going, though, one of the higher-level problems that's remaining is data is expensive, right? This goes back to Google using data as a moat. It's not algorithms. It's giving away the algorithms. But it likes data so much, it loves data so much, that it even buys satellite companies for imaging. So, and they're going to charge you tons of money or not even give that to you. So what is the ultimate way to unlock data? We believe that it is data exchanges. And with that, we are actually spending significant effort working towards making data exchanges to power AI algorithms. An example that we actually just announced today, are announcing here even, is a decentralized data exchange for self-driving cars. We're doing this with Toyota and many others. And basically what this is it turns out I can build an algorithm that is 99% accurate for self-driving cars. But what that means is 1% of the time it's going to crash. It's maybe even going to kill someone. So you can't be just 1% error. You can't be 1 in 1,000. You can't be 1 in a million. You really need to be 1 in a billion or 1 in 10 billion chance of error. But to get there, you need a lot of data, more data than any single car manufacturer can make. So what Toyota and the others are doing is pooling their data. And not just pooling it and sharing it, but actually selling it to each other. How are they determining the prices? As an exchange. Automatic determinant, the list of bids, the list of asks, and so on. So what you see here actually is an app. We call it AVDEX, Autonomous Vehicles Data Exchange. It's once again a single-page web app running in the browser. You log in. You actually choose your username, password, all this with a Brain wallet. And you can see here that we actually have the data that is ascribed to the blockchain. And in this case, it is IPDB. Another angle from the AI perspective is self-driving cars are the killer app for AI. And that's actually very true, especially in the next 5 years. It's going to have massive ramifications in society. And we're very excited because we see that this will help to unlock safe self-driving cars. I have one final example for you people, and it's probably the craziest, but also the most fun. It's really a symbiosis with AI and blockchain. I call them AI DAOs, Artificial Intelligent Decentralized Autonomous Organizations, AI DAOs. For some background, so there's a whole subfield out there of AI research on machine creativity. One example, my friend Greg here, while he was a scientist at NASA, he had a side project where he was automatically designing jewelry. So every single one of these pieces of jewelry you see here, pendants for necklaces, are actually automatically designed. And he actually set up a startup that he called Orbimi that was actually automatically designing these on the fly. Just like Amazon was the Earth's largest bookstore, Orbimi is actually Earth's largest jewelry store. There are billions and billions and billions of designs in there. And you click and you click and you click until you get the one you like. And then it automatically 3D manufactures it. You buy your jewelry. So machine creativity is here, folks. I actually did my PhD in this back about 10 years ago as well. So I was actually automatically designing wholly new analog circuits. Here's some examples here. So take that. Let's also take the idea of artificial general intelligence, AGI. So this is the idea, rather than just solving narrow AI apps, instead you have agents that sense, model, and act. For example, they can run around in Minecraft in a simulated environment. And in fact, you can frame them as control systems. A control system, a feedback control system, has a model of the world, and then it actuates against that world, senses what's going on, and tries to update that model of the world and itself. So it's actually a well-studied thing because this theory goes back to Wiener in the 50s and ever since with all the control systems theory. By the way, this framing of AGI is actually what drove AlphaGo in the recent successes with solving Go a couple years ago. So let's come to this example as a really nice way to think about AI DAOs. I call it the art DAO. Here's how it works. Step one, you have an AI art engine to generate a new image, right? Off-the-shelf software, 50 lines of code, 100. Then you claim attribution in the blockchain, just like I showed you before with Ascribe or with my carts. And then you post them for sale onto a marketplace. And of course, you'd use a decentralized marketplace like OpenBazaar, right? And then you sell them. And by the way, when I say you, I don't mean you. I mean the agent that is running on decentralized processing substrate, right? And by the way, it has its own wallet, of course, right? Think of it like a computer virus with a Bitcoin wallet, right? But it's running out there. It's creating these things that have value, and it's selling them. People are buying them. So what happens is, let's say it spends $1 of compute power to create this art. It sells 10 editions for $1 each, makes $10. Then it turns that around, spends $10 to create 100 new editions, sells those. Keeps going, 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 goes from $100 to 1,000 to 1,000,000 and beyond. We will have the world's first AI millionaires with technology of today. Maybe even the world's first AI billionaires, right? So to me, that is super exciting. I should mention that it's also, there are benefits. It's not just an art experiment. For example, if you are Uber and you want to do self-driving cars, do you actually want to buy all of those self-driving cars? That's a lot of capital. Why not let them be self-owning self-driving cars, right? Let them buy themselves from Uber, right? Self-owning forests with TerraZero, there's other things too. So these AI DAOs actually have a real reason, and that is for capital efficiency, right? It's a double-edged sword too, quite dangerous, and we can go on and on. But I will summarize now because I think they're cool. We could go on and on. Come talk to me afterwards. So I'm going to summarize saying AI has helped drive Moore's Law. Moore's Law has helped drive AI, especially the data and the compute. But here's the cool thing. Blockchains are going to make a big difference to the world of AI for everything from data sharing, for better models, as opposed to the data hoarding, provenance on AI and models, exchanges for AI and models, and I really see that this will become fundamental internet infrastructure. Just like the emerging file systems are becoming fundamental internet infrastructure, emerging databases and so on, it will also be the same for data exchanges. And finally, AI DAOs, the world's first AI millionaires. Thank you very much.